Hello everyone, in this video some selected past exam problems on differential calculus will be solved. Don't forget to subscribe, like and comment. The first question, it says f be differentiable function and f of 1 is equal to -1 and f derivative at 1 also is equal to 1. These two are given, and there is a second function g of x which is f of 2x plus 1 plus 2 the whole square. And then what's asked? The derivative of the g at 0. So what to do to get the derivative of g at 0? First derive the g and then substitute 0 in place of x. Let's derive the g. The derivative of g of x will be, first of all, this exponent will be a coefficient, so 2 times 2x plus 1 plus 2, then the exponent will remain 1 because we reduce by 1, but chain rule has to be applied here, the inner derivative, but you know 2 derivative is 0 since it's constant, and plus, forget it, focus on here. The derivative of this function will be f derivative of 2x plus 2 plus 1 times, still the function f has another inner function, that is 2x plus 1, when we derive it is going to be 2. So 3 functions are there. 1, the power, it is, you know, the exponent comes here and remain as it is. Second, by chain rule, the inside one. The inside one, it has 2 function, the f and inside. The plus 2 will be constant, so we can ignore. So let's substitute now 0, since we need to find the derivative at 0. G derivative at 0 will be 2 times, when you insert 0, this will be 0, again here will be 0, so 0 plus 1 will be f of 1 remain, plus 1, plus, plus 2 here, and there is no plus here, times f derivative at 1 times 2. By the way, the question has to be g derivative at 0, it has to be corrected. Then since f of 1 we have -1 and f derivative at 1 also it's 1, when you finalize, you know, -1 plus 2 will be 1 times 2 will be 2, and this is what doesn't have any effect, it will be multiplication, so times 2, 2 times 2 remain, finally the answer will be a, that is 4. The second question, we have a function f of x which is ln of 2 the power of tan x. Then what's asked? The derivative of this function. In this function there are 3 functions composed each other. The outer one is the ln, and the next one is exponential to the power of something, and the third function is the power, that is trigonometric function tan. So we have to apply chain rule and derive step by step. So the derivative of the function will be, first the ln derivative. When you derive the ln, it will be, remember, ln x derivative, that is 1 over x. So I have to do here 1 over everything what we have here, to the power of tan x, times to the power of something we have. So again we need to recall exponential derivative, that is a the power of x times ln a. So 2 the power of tan x times ln 2. Again I have to multiply. The next function is tan. The derivative of tan x will be sec square x. So this time 2 the power of tan x will be cancelled, and then what remain? Ln of 2 times sec square x. This is the derivative of the function at x, but the question was supposed to be f derivative at 0, so we need to substitute 0 now. F derivative at 0 will be ln 2 remain as it is because it is a constant. We need to substitute 0 here, only sec square of 0. You know, sec is the same as 1 over cos, so sec x means 1 over cos x. So sec 0 is the same as 1 over cosine 0, and cosine 0 is 1. So when you square it, it will be the same. 1 over 1 means it's 1. So the answer is going to be just ln 2. So still the answer will be A. The next question, we have a function h of x square root of 1 plus radical x. Then we need to find h derivative of x. So here again chain rule will be applied to function composed outer square root and the inside. And let's record radical x derivative will be 1 over 2 times of radical x. So h derivative of x will be, first outer radical, it's going to be 1 over 2 times square root of 1 plus root x times the inner derivative, that is 1 plus radical x also will be derivative. But one derivative is 0, so only radical x derivative is going to be 1 over 2 radical x again. So finally h derivative of x will be 1 over, I will multiply this. In the numerator we have only 1, so only 1 over remain. 2 times 2 will be 4 radical x times square root of 1 plus square root of x. Since it is multiplication, we can keep them in one radical, so it can be written 1 over 4 in the square root. This x will multiply each of them in one radical, so x plus x root x. This could be the answer, which is B. The next question, we have a function f of x, which is 2e the power of x minus k sine x plus 1. And this function has tangent line equation already given. Y is equal to 5x plus 3. The equation of the tangent line for this function, it is y equal to 5x plus 3 at 0, 3. From this we can take out the slope will be 5. This the slope means the derivative of the function f at 0, because the slope is the slope of the tangent line means the derivative of the function at the tangency point. So this is equal to 5. We know this. So first of all, let's derivate the function. The derivative of the function will be, when you derivate this one, it will be the same to e the power of x, because e the power of x derivative will remain the same, and sine derivative is cos, so minus cos x minus k times cos x. One derivative 0. So now the derivative at 0 means I will insert 0 in place of x everywhere. 2e the power of 0 minus k times cosine 0, which must be equal to 5. We said it before. But this is 1, also this is 1. So what remains? 2 minus k is equal to 5. So let us change the place of the k in the 5. Let's take the k to the other side. So 2 minus 5 is equal to k. So k should be negative 3. That is B. The next question says, which one of the following is equal to d by dx of logarithm of square root of 6x to the base 2? Here three functions are composed each other, logarithm, square root and 6x. So first of all, let's recall the derivative of logarithm. Logarithm of x to the base a, when you derivate, it will be 1 over x times ln a. So in our case, we need to find d by dx of logarithm of square root of 6x to the base 2. So this is equal to 1 over square root of 6x times ln 2. This is the derivative of the logarithm, just only the logarithm derivative. Then I have to multiply and continue the chain rule times the derivative of the radical will be 1 over 2 radical 6x. Again, I will derive the inner function. The 6x derivative will be 6. So when you finalize this, upper 1 times 6, 6 remain. Lower, radical 6x times radical 6x will be 6x, and there is times 2, then ln 2. So when you simplify here, you can cut 6 with 6, and then finally the answer will be 1 over 2 times x will be 2x ln 2. So the answer will be A, not D, it's A. Next question, we have again a function f of x which is ln of x times square root of x. Then again we are asked to find the derivative of x. Again here we have two functions, outer ln and inside another two functions multiplied, so we have to apply chain rule. The derivative of f of x will be the ln derivative, it's going to be 1 over of the function x root x times the derivative of the upper one, x root x derivative. But how to derive x root x? X radical x can be derived by product rule, or we can simplify first, x the power of 1 and radical x means x the power of 1 over 2, so we can add the exponent. But let's apply product rule here. X derivative times root x plus x times root x derivative. So x derivative is 1, so root x plus x over 2 root x. Radical x derivative is 1 over 2 radical x. So we can write it in this way. This means over 1. We can use crisscross. Radical x times 2 radical x will be 2x plus x over 2 radical x. That's going to be 3x over 2 radical x. So the derivative will be now 1 over x radical x times, what do I have here? 3x over 2 radical x. Then we can simplify this x with this x because it's multiplication. So upper we have left only 3, lower root x times root x will be just x, so 2x will be remain in the denominator, so the answer will be D. The next question, we have a function f of x which is k times ln x plus e the power of sin x. Then we are given the second derivative of this function x is equal to we need to correct this question first of all. So the question was supposed to be, the given one was supposed to be f second derivative at pi. This was supposed to be pi, which is equal to -1, so we need to correct it. This must be pi. Then we need to find the k. The second derivative of f at pi means derive this function twice and then substitute pi in place of x, then which is equal to -1, then we can find the k. So let us derive f twice. First derivative of f, k times ln x, derivative will be k over x. Ln x derivative is 1 over x, so plus e the power of sin x derivative will be e the power of sin x times the sin x derivative is cos x. This is the first derivative. So when you continue derivating, the second derivative will be k over x derivative will be -k over x square. How comes? 1 over x derivative is -1 over x square. So the k is constant, it doesn't have any effect. So when you multiply, -1 over x square will be the derivative. But for this part we need to apply product rule, because two functions now multiplied, cosine and e the power of x. E the power of x derivative will be the same, e the power of sin x times again sin x derivative cos x, so cos x times cos x will be cos square x plus then the first as it is times the second derivative. That's going to be cosine derivative is negative sine x e the power of sine x. This is the second derivative. What did I do here? Take care. First I will derivate this one. You know, if two functions are multiplied, f times g derivative will be f derivative times g plus fg derivative. So e the power of x, e the power of sine x derivative by itself will be itself times the exponent derivative by chain rule, cos. It's going to be cos. Cos times cos will be cos square. Then plus, it was supposed to be plus, the second derivative, that is the cosine derivative, is negative sign. That's why this remain negative. So that's it. Now let us substitute pi, because second derivative at pi given already negative 1. So the second derivative at pi mean negative k over pi square in place of x. I will substitute pi plus e the power of sine pi times cos square of pi minus sine pi e the power of sine pi, which is equal to negative 1. Okay, so what is sine pi? You know, it's 0. Cosine pi is negative 1, but negative 1 square will be, you know, it's 1. So this is also 0. You can ignore this part. This is also 0. But you know, 0 times anything will be 0. So this part we can forget it. So what remain here? Negative k over pi square. E the power of 0 means it's 1. Here also 1. So 1 times 1 will be just plus 1 remain, which is equal to negative 1. Then we can exchange the place, shift the case to the other side and bring the negative 1 to the left. So 2 is equal to k over pi square remain. If you multiply by pi square, the k value will be 2k square. I mean 2 pi square. So the answer is going to be A. The next question, it says, what is the slope of the tangent line to the graph of the function f of x? 3e the power of x plus sine x plus 2 at 0, 5. We need to find the slope only. The slope is the derivative of the function at the first point, that is at 0. This is what we need. So slope of tangent line for a given function means derive the function and then substitute the first order or what's given here. Let's derivate it. Derivative will be, the first derivative will be 3e the power of x as it is, plus sin x derivative will be cos x. You know, 2 derivative 0. Now when you substitute 0, 3e the power of 0 plus cosine 0. E the power of 0 is 1, so 3 plus 1 remain. Cosine 0 is also 1. So finally the answer will be 4. That's going to be the slope, D. Our next question, if a function f is differentiable at a function is differentiable at a implies, or what does this mean? It is continuous at a. Differentiability implies continuity, but continuity doesn't imply differentiability. So a given function, if it is differentiable at a point a, we can say it is continuous at a point a. Okay, if it is continuous, what condition or what precondition has to be satisfied? The limit of the given function as x approaching a, it has to be the same as the functional value a. So here, what will be the limit value of this function? It's the same as the functional value, which is a. Next question, what is the equation of the tangent line to the graph? Again, we have function f of x, which is 3x squared plus 4x minus 5, and we need to find equation of tangent line at a point 1, 2. So first let's get the slope. The slope means the derivative of the function at 1, like we did before. This is what we need first. So what's the derivative of this function? It's derivated. The derivative of 3x squared will be 6x, and the 4x derivative will be 4. So when you substitute on this derivative 1, because the first order here it is just 1, you know it's going to be 6 times 1 will be 6 plus 4, 10. This is the slope. So what will be the equation of the tangent line? The equation of the line would be y minus the second order here it is 2, which is equal to the slope is 10 in bracket x minus 1. So y minus 2 is equal to 10x minus 10. When you take the 2 to the other side, y is equal to 10x minus 8. So if we collect everything to the left side, 10x plus y plus 8 is equal to 0. But we cannot get this in the choice, so we can multiply each of them by negative. Finally 10x minus y minus 8 is equal to 0 will be found there. That is A. Next one, x squared plus xy equals 10, and then we need to find dy by dx at x is equal to 2. First we have to find the derivative of y with respect to x. So for that matter, let's try to make the y alone. So shift x squared to the other side, so xy is equal to 10 minus x squared, then divide by x, then the y is equal to 10 over x minus x. So dy by dx will be negative 10 over x squared, because 1 over x derivative is negative 1 over x squared. The 10 is constant, so minus 1. Therefore dy by dx at x is equal to 2 means I'm going to insert now the 2 in place of x, so negative 10 over 2 square minus 1 remain. That's going to be negative 10 over 4 minus 1. That will be negative 14 over 4. That is negative 7 over 2. We can simplify. So the answer is going to be A. The next one, we have a function f of x which is ln of x squared plus 2, and then we need to find f second derivative at 1. The first derivative of x will be, since it is ln 1 over the function as it is x squared plus 2 times the inner derivative, that is 2x, which is 2x over x squared plus 2. This is the first derivative. So when you go to the second derivative, we need to apply here quotient rule, because two functions we have here, upper and lower. So the quotient rule says the upper derivative times the lower as it is minus the upper as it is times the lower derivative, the whole over the lower function square. So here 2x derivative will be 2, and here also x squared plus 2 derivative will be 2x. When you finish it, the 2 will multiply each of them, so we'll have 2x squared plus 2. Here we'll have 4x squared generally. Let's try to use another marker. This is 2. When you multiply it, it will be 2x squared plus 4, and here it will be 4x squared. So when you finish it, it will be 4 minus 2x squared the whole over x squared minus plus 2 the whole square. Now the second derivative at 1 means when we insert 1, it's going to be 2 over 1 plus 2, 3 square 9. So the answer will be 2 over 9, that is D. Next one, we have capital f of x, which is equal to f of 2x plus 2 times g of 1 minus x square. So the capital F, it is a product of two functions. Those are f of something times g of something. So we need to apply product rule to derivate. But finally, what's asked? We are asked the derivative of this function at 0. So we have to derivate f anyways. When you derivate, we need to apply product rule. But don't forget, f by itself here, it is composition of two functions. The outer f and there is inner linear function. The g also the same. The outer g composed with another quadratic inside. So we have to, when you derivate the g, for example, we have to derivate the g and the inner also. But first of all, when you see like as it is, there are two functions multiplied, f times g. Okay, so what will be f derivative of x? First up, derivate this one. It's going to be f derivative of 2x plus 2 times 2. This the whole thing is the derivative of f only, because f derivative times the inner derivative is 2 times g of 1 minus x square. Let's go to the g again, plus product rule. First derivative done, times the second function as it is, plus the first function as it is, f of 2x plus 2 times the g derivative will be g derivative of 1 minus x square times negative 2x, because negative x square derivative will be negative 2x. Here negative 2x. So what do we need? We need a derivative at 0. So f derivative at 0 will be, I will substitute 0 everywhere in place of x. So this will be 0, again this will be 0, again this will be 0, here also 0, and here also in bracket 0. But this bracket, it's a problem, it will make everything 0, because 0 times anything will be 0, again times 0, it will be 0. So what remain? F derivative at 2, because here 2 only left, times 2 times g of 1 remain. Do we have f derivative at 2? Yes, it's given. F derivative at 2, it's here, that is 4, multiplied with 2 times g of 1 also, it's given to us, g of 1 is equal to negative 5. So when you multiply, you will get negative 14. So the answer should be A. Next question, we have a function f of x, 2 plus absolute value of x minus 3, and then what is the derivative of this function at 3? First of all, let's remove the absolute value. What means absolute value of x minus 3? This is the same as x minus 3 or negative of x minus 3. When x minus 3 greater than 0 and when x minus 3 less than 0. What does this mean? This means when x greater than 3 and the lower part when x less than 3. And again, when you finish this bracket, when you remove the negative, it will be negative x plus 3. So our function f of x will be now, f of x will be 2 plus x minus 3. I will take the first part when x greater than 3, and again 2 minus x plus 3 when x less than 3. When you simplify it, this is the same as x minus 1, because 2 minus 3 is minus 1 when x greater than 3, and 5 minus x when x less than 3. So what will be the derivative of this function? The derivative of this function will be either 1 or negative 1. The upper derivative is 1 and the lower derivative is negative 1. So when x greater than 3 and when x less than 3. This time the derivative of the function at 3, okay, from the right side, and the derivative of the function at 3 from the left side. from the right side it must be 1, from the left side it must be -1, as you see here, the derivative. So they are not equal. So the right hand and the left hand derivative at that point is not the same, means the function or the derivative of this function at a point 3 doesn't exist. Next one, again we have a function f of x which is equal to 1 minus 3x squared and ax plus b when x less or equal to 1 and when x greater than 1. Then the function is differentiable at 1 given. So we are asked to find a and b. So if it is differentiable, let's derive it. The derivative of the function will be -6x, the upper part, and the lower part is just 1 when x less than or equal to 1 and when x greater than 1. Since it is differentiable at 1, the derivative of this function at 1 from the right side, it must be equal to the derivative of the function from the left side. When I say from the right side, it should be a. From the left side it has to be -6x, but I will insert 1. I will insert 1, so it's going to be -6. So a should be -6, so which choice containing a equal to -6, that is D. The answer will be D. But how the b comes? If this function is differentiable at 1, it must be continuous at 1. If it is continuous at 1, we can say the limit of the function as x goes to 1, it should be f of 1 from the right or 1 from the left. But when I say f of 1, I will take the first part, so I will substitute 1 in the first part. That's going to be 1 minus 3. So for the limit I will take the second part, that is a plus b. I will insert 1 in place of x. So but the a I know it's -6. -6 plus b is equal to -2, so b must be equal to 4. So to get the b, we need to apply continuity. Differentiability implies continuity, but continuity doesn't imply differentiability. So the answer obviously will be D. Next question, we have a function f of x which is e the power of 3x cos x minus x plus pi over x squared plus 2. We need to find the derivative at 0. What will be the derivative? For the first part, we need to apply product rule. The derivative of the e, which is e the power of 3x times 3, then cos x plus cosine derivative will be negative sign, so I can write here minus e the power of 3x sine x. From where this minus come? From the derivative of cosine. But what I did until now is only the first part. For the second part, I will apply quotient rule. The upper derivative is 1. There is minus here, don't forget. 1 minus the lower is x squared plus 2 minus the lower derivative is 2x. It will multiply the upper one. 2x squared minus 2 pi. The whole over, x squared plus 2 square. Then the derivative at 0 means, now I will substitute 0 everywhere. This will be 0, this also will be 0, this is also 0, cosine 0, sine 0 is 0, but cosine 0 is 1, and then so when you insert everywhere 0, this also will be 0, this is also 0, and this is going to be also 0. So finally, when we simplify, it's going to be, but here we need to take care, this must be 2x pi. How comes? the upper derivative is 1 times the lower, here it is, and the lower derivative is 2x multiply the upper part, it will be 2x square minus 2x pi. So this is also 0. So what remain? Just 2 over 4 remain. The upper part 2 and the lower 4. So 2 over 4 means 1 over 2. When you subtract, the answer is going to be 5 over 2, which is D. Next one, we have a function y which is equal to sine of 3x square. And then we need to find d square by dx square of y. Means we will derivate the y 2y's. So what will be the derivative of y? Y derivative will be, sine derivative is cosine of 3x square times, by chain rule the inner derivative is 6x. Done. When you go to the second derivative, product rule we applied here. 6x derivative will be 6 times cosine of 3x square as it is, plus again cos derivative is negative sine of 3x square times 6x. So when you finish it, it will be 6 cos 3x square minus 6x sine 3x square. So the answer should be okay, times 6x is there. The cosine derivative only will be this one, and there will be 6x. When you multiply, it's going to be 36 x square. It should be. So the answer will be C. Next one, again we have a function f of x which is equal to e the power of 2x sine x, and then again we need to find this twice. We need to derivate twice. So the first derivative will be product rule. E the power of 2x derivative will be 2 times e the power of 2x. We know by chain rule 2x derivative will be 2 times sin x plus e the power of 2x times sine derivative is cos x. We can simplify this. It can be written e the power of 2x in big bracket 2 sin x plus cos x. Now when you derivate for the second time, again the outer derivative is 2 times product rule, again the outer times the inner one. The outer derivative alone will be 2 times e the power of 2x. This is only the e the power of 2x derivative times 2 sin x plus cos x, plus the outer as it is times the inner derivative 2 sin x will be 2 cos x minus sin x. Cos x derivative is negative sin x. Again let's take out negative e the power of 2x outside. Then what remain? These two will multiply each of them. It's going to be 4 sin x plus 2 cos x plus 2 cos x minus sin x. So finally this is going to be e the power of 2x in big bracket 4 sin x minus sin x will be 3 sin x plus 2 cos x plus 2 cos x is going to be 4 cos x. So the answer should be C. The next question, we have a function f of x squared times square root of 2x plus 12. Then we need to find the slope of the tangent line at 2 means we are asked simply the derivative of the function at 2. First let's derivate it. What will be the derivative? Product rule will be applied here. Two functions are here. So x squared derivative times square root of 2x plus 12 plus x squared times square root of 2x plus 2 plus 12 derivative. Okay, this is equal to x squared derivative is 2x, square root of 2x plus 2, 12, plus x squared times, what is this derivative? 1 over 2 times square root of 2x plus 2, because radical derivative will be 1 over 2 times, so this 12, times, by chain rule the inner derivative is just 2, because 2x derivative will be 2, and then we can cancel these 2 with 2, and then what remain, you know, is the same as x squared over x 2x plus 12 in the radical. This is the second addend, only the second part. Now let us insert 2. The derivative at 2 means when you insert this it will be 4, when you insert 2 this will be 16, from the radical will be 4, plus here also when you insert 2 it will be 4, and the lower part of 4, so 16 from the radical 4, so this will be 16 plus 1, that is 17, so the answer should be D. The last question for today, we have a function f of x, which is x squared over 1 plus x g of x, and then we are given g of 2 and g derivative at 2, so we need to find f derivative at 2. So first let's derivate the f derivative of x. Will apply quotient rule here, the upper derivative times the lower as it is, 1 plus x g of x. So by quotient rule, the first derivative times the second as it is, we have two functions up and down, minus the upper as it is times the lower derivative over the lower square. But x squared derivative is 2x, here it is, and this will remain as it is, so the function will be 2x in big bracket 1 plus x g of x, minus, but the second derivative here, one derivative, you know, 0, but this one product rule, x derivative times g of x plus x times g derivative of x, but x derivative again it's 1 times g of x will be, g of x remains, so x squared in big bracket g of x plus x g derivative of x, the whole over 1 plus x g of x square. Now let us insert the number 2. When you insert 2, here will be 2, and g of 2 will be given, it's 1, and here also 4, and g of 2 again it's 1 here, and again here 2, g derivative at 2 is also it's given to us 10, and the lower part also here 2, we need to insert 2 times, this is 1 when you insert 2, so finally f derivative at 2 will be you know, here 2 times 1 2 plus 1 3 multiplied by 4, that is 12, minus 2 times 10 20 plus 1 21 times 4 is 84, the whole over 9, you know, the lower part 2 times 1 2 plus 1 3, the difference will be negative 72 over 9, so it will be negative 8. The answer is going to be A. These are some of selected problems. Hopefully you have got some ideas, and I will continue with additional questions. Thank you for watching.